Good morning, sir.
Yeah.
And we'd like to firstly thank you for your sparing your time for this interview. My name is Saurabh Nathu. This is Apurva Shah, and we're both from third year physics. And as a part of our assignment, we're going to interview you about some of your background right from your childhood to your recent work on the gravitational waves.
It's a pleasure for this interview.
Thank you, sir.
We'd like to begin this interview by asking you about your childhood and what attracted you towards science when you were a child.
Okay, actually, it is so far back in the thing that I don't quite remember. As I remember, I was always interested in science. So, even from the age of 6, if I go back, even at that time, I remember I was interested in mathematics, for example. I mean, at that time, the mathematics was just arithmetic. But doing sums, as they were called, not only additions but multiplications. I could multiply 3-figure numbers and so on, by 3 figures and so on. So it was, I was always interested in this thing, also in physics. And I remember my first interview when I was taken into school, where the principal asked me some questions. And some of the questions were so elementary, like 3 plus 5, what is 6 into 9, and things like that. I found them a bit ridiculous when I was at that time. I didn't quite understand why they were asking me such questions. But I was always interested in mathematics as well as physics. And physics, mostly magnets and so on, they fascinated me.
So you were always ahead of all other kids of your age.
Yes, in this thing at least. In physics and mathematics. Not maybe other things.
Right.
So, would you say you believed in discovering things by yourself rather than taking things for granted that are given in
yeah.
books?
Yeah, exactly. Like, for example, I don't know at what age, but maybe something like 7 or 8, or when I was just able to read, I read about the electromagnet. So I didn't quite believe it that it would work like that. So I constructed one myself.
Okay. Continuing on that
Yeah.
thought, would you like to say that you didn't take things for granted that was stated in books, and would you say that you like to discover things on your own?
Yes, precisely that was the thing. That, for example, I was interested in magnets, permanent magnets, and so on. I used to play with them. So this was when I was 7, 8, or something like that. And there, at that time, I read about the electromagnet. And so when I read about it, I didn't quite believe it, that it would work the way they said in the books. So, so I myself made this electromagnet.
Right.
By odds and ends, I got some piece of iron, got it heated on the shigdi, and then after that, bought some enameled wire and coiled it around it, and I was extremely surprised and happy that it worked. And as it worked as if it was like in the book.
Right. It does seem like a magical
So,
object.
yeah, it looks
from,
like a magic
yeah.
thing. Yeah.
So you studied in Ferguson College. Can
Yeah.
you talk about your days that you spent there?
Yeah, so I joined the Ferguson College. I was there for 4 years.
Right.
So so we had 11th standard. So we did 11th standards in the school. After the 11th standard, we went into the college, and then we had a pre-degree and then 3 years, first year, second year, third year, like that.
That's different
Yeah,
from
different
what it
things.
is
So,
now.
so the pre-degree was all sorts of. So I went into science, and then all sorts of things were there. All subjects were there. Then FY we had we could take something. Then SY group like physics, statistics, and mathematics. And finally, I took mathematics as the last, the final year.
So you majored in mathematics and not
mathematics,
physics.
Yeah. And one thing there I want to say is that one of the teachers, I think in my whole education which I've had till whatever, MSc or something, till lectures were given to me and so on. I think probably the best teacher was I encountered in Ferguson College, who was Mrs. Madhumalti Apte, who taught us mathematics. I think I encountered her maybe twice during the 4 years, suddenly in the last year.
Okay.
Yeah, so there where she taught us thing, and she was very good. Now I can understand why she was good, because the reason was that she had a full perspective of the field. Since she had this perspective of the field, I think that makes a difference to the students,
Right.
because then they can explain extremely well the relevance of the subject.
Right.
It's not just teaching something from the book.
Right.
It's also got to do something with what is the application, where did it come from, how did it originate. So all these things, I think they are brought out if a person has a perspective.
So she had more applied knowledge, like she could explain the mathematics in an applied manner rather
No,
than.
not like that. I mean, there are applications in mathematics itself.
Okay.
Right.
It's not applied thing
Okay,
like that. So, I mean, I think that feeling was there. I mean, not that she taught us anything like that, but one could see it. Similarly, here in MSc also, that way there was a teacher, like who is here in IUCAA, Dadij.
Okay.
He taught us relativity, general relativity.
Okay.
And that is the only subject I found basically very interesting. And it is a curious fact that I encountered general relativity or the field because I went through mathematics. If I had gone through physics, I would not have come to general relativity, although it is physics.
Right.
So this is a very strange thing. At least it was a strange thing in those days. Now I hope it is being corrected.
They
This
slightly
situation.
have, yeah. They're
Yeah,
starting to introduce special
yes.
relativity at least
Special
now.
relativity is not enough. You
Right.
must have also general relativity.
Yeah.
In masters,
Yeah,
they do
masters.
introduce
Yeah.
these courses now.
Yeah. Because it should not remain in mathematics. That's my feeling. This particular subject.
True.
It is actually a physics subject and should be dealt with by physicists. That is the important thing.
So apart from academics during your days in Ferguson College, what all did you do, like as extracurricular activities?
Yeah, I think
even?
in Ferguson College I engaged more in extracurricular activities rather than more in academics. So like music was my another second passion.
Okay.
So was cricket. So both these things I engaged in, but more in music, I think.
Okay.
I mean, many of the what they call pada in Marathi. That is the thing of this natak, Sangeet natak was there. All these things. And I used to play songs from that on the organ.
Okay.
And the reason was that my father was interested in this thing, music, and mostly great this thing follower of Bal Gandharva.
Okay.
He used to also accompany him on the organ
Right.
for Bal Gandharva. So these instruments were there in my house, in our house, and so I used to play this organ and so on. But I was not only interested in that; I was interested also in the Western part of the music.
Right.
And because in school they taught us, hymns and Christmas carols and things like that. I was in Spicer and later
Okay.
in Loyola.
Right.
So you would say that if not science, you would be pursuing music as a career
music
option.
was my very another big passion. So was cricket. But cricket, I think, it was more or less limited, somewhat
Okay.
limited. Though I have actually faced test class bowlers.
Oh,
In TIFR, we got by some chance.
okay.
I mean, test classes, he didn't play test, but test batsman was there. Ramnath Parkar at the time. He was
Okay.
open with Gavaskar in one of the series. So he played against us.
So can you tell us about your work in gravitational waves?
So in gravitational waves, the thing is, see, I got interested in this because of many things. Because I was interested also in engineering at the time. I mean, electronics and all that, I was interested. So, not only mathematics, I was interested in physics, electronics. I mean, I built my own amplifiers, power supplies, and things like that.
You built them on your own.
On my own.
We don't even do
Huh?
that now with the availability.
No, but all those things I did at the time. So electronics and all that, I was quite interested. Engineering, I was interested. And this project came up. I mean, this particular field came up it was extremely interdisciplinary. That means it involves lasers, vacuum techniques, general relativity, statistics, mathematics, even the most sophisticated kind of mathematics.
Right.
That's the kind of mathematics which I put in the, so this field, I think a lot of the differential geometry, as it's called, I put in, I mean, that is my contribution, I think, in this field.
Right.
Okay.
Is that introducing differential geometry into this field of how to extract the signal from the noise, from the statistics.
Right.
Putting differential geometry into the statistics, of course, it's already there. People have used differential geometry in statistics. But I use that in gravitational waves, the same kind of thing. And so this interdisciplinary character, right from engineering aspects to physics to mathematics and statistics, all come in gravitational waves. I mean, and so that is what attracted me to this field a lot.
Okay.
And that is what I have said actually. Yesterday, I think there was a reporter who called me
Okay.
for saying, because I think it's a university now, Ferguson College.
Yes.
Yeah, I just
Yeah,
recently
so,
became
Yes.
a
so
university.
what did you think? So they asked me, what do you think would be the best thing? So I said that this gives you flexibility
Yes, it does.
for
Very much.
making
Yeah.
courses
Yeah,
and all
yeah.
that. So there should be now more the things like interdisciplinary courses.
Right.
I mean, not just physics. There are physics and there is mathematics and so on. So, I mean, I can't tell where is the line between physics and mathematics.
But they
So
overlap.
But they overlap
overlap
and
so
merge
much,
into each
right.
other, just like colors match into each other. It's all there in this paper, newspaper. you
Okay.
see.
So, what do you think your experience was during the research, like when you were doing research for
Yeah.
detection of the gravitational waves?
Right.
So, how was your experience during that period,
So,
working with so many people and
Right. So, I mean,
getting
I had a
something.
group here in IUCAA working with me and so on. So, at that time, when I started working, I think everybody was skeptical.
okay,
I mean, of this thing, that this is an
Something.
impossible task.
Right.
I mean,
Right.
this will never happen. And that kind of thing. So, it was a big challenge to do all these things. And but I think it was so interesting and fun doing the whole thing that I carried on. I mean,
okay,
so I believed that at some point they would be detected. That I was sure, but
You
I didn't know
completely
when.
believed in the idea.
I mean, I was quite sure of basically a relativistic theory of gravity,
right,
which was Einstein's theory. General relativity is one such
Right.
theory, and that is the best theory because, as we know it up to now, all the experiments done so far, they have sort of been consistent with general relativity. And the prediction of general relativity is gravitational waves.
right,
And so I said that, I mean, they have to be there, if that is the thing. The question is whether we'll detect it, whether we'll have sensitive enough instruments, whether our sources will be strong enough so that our instruments can detect it. That was the basic question. So that I didn't know when it would happen. But I was sure it would happen when the space detectors came. Unfortunately, that has been pushed ahead. But at the time, in 30 years back, these things were thought of like they would be there in the early 2000s.
Okay.
The LISA project, the Laser Interferometric Space Antenna.
right.
That project would be up in, at that time it was thought to be like 2010 or 12 or 13. But now
But now it is delayed.
Yeah, it's
Yeah.
235 or something.
Okay.
But I was sure that these projects will certainly detect
Okay.
gravitational waves. And the ground-based, I didn't know because we did not know we would have strong enough sources or whether we could reach how much sensitivity so that we could detect such sources.
Right. So, what do you think lies in the future for gravitational wave astronomy?
Yeah, it has just started. The field is now, it's begun. It's the detection is, it's not the end of the field. It is in fact the beginning.
Right.
Especially with LIGO India.
Yeah,
being
with
a major
LIGO
step
India,
forward.
yeah, so it will add to the whole network of detectors.
Right.
So this is just started. So next 100 years, I think, is for gravitational wave astronomy. Just like optical astronomy started in 400 years ago.
Right.
with Galileo. Okay, so there were, there was a telescope. He turned the telescope to the sky, and he saw the moons of Jupiter. So this was Galileo's contribution. That I mean, the optical astronomy. He was the father of optical
Right.
astronomy.
Right.
Yes.
And then radio astronomy started. That was in the last century. So 1930, 40, 50. And that brought us a lot of surprises and things like that. But it takes time. So radio
Yeah,
astronomy
to
is still going
develop
on.
such large
Yeah.
instruments.
So now it's almost 100 years or maybe 70, 80, 90 years since that is going on. And that has brought us a lot of information about the universe, complementary to what optical astronomy told us. So I think that's the same role now gravitational wave astronomy will play. So I think again for the next 100 years or maybe 200 years, this is the field. So it
Right.
has started now. That's what I'm saying.
Right.
It's like what I say is it's like a newborn baby. It's like discovering electromagnetic waves. Exactly like
Right.
that the situation. Like Hertz discovered or showed experimentally that electromagnetic waves existed. They were predicted by Maxwell's equation
Yeah.
Yes.
in 1860 or something by Maxwell. But decades later, 30, 40 years later, Hertz experimentally showed that they
Right.
exist in the
Right.
laboratory.
Right.
So the similar situation is here. And even at that time, it was not clear what the electromagnetic waves will do. But now I can't imagine life without electromagnetic waves.
Right.
I think a similar situation will come with the gravitational waves, maybe
Right.
100 years later.
That'd be interesting. Very.
So this was 1890,
Right.
the electromagnetic waves, and this Hertz experiment was in 1890.
Yes. So, what message would you like to give to people of our age who are hoping to make a career in physics?
Yeah, now there is a big chance, I think, for people, young people to get into science, and there are so many exciting projects. See, it's not as if this is done and it's over. It's not never like that. Basically, I think there's a lot of science which is done, and generally that's the foundation which is laid by
Right.
many people earlier. So that is given to you. So that is your inheritance. You can take that. And you can take it and then you can build on it. The
Right.
main thing is to
Right.
build on it. So
Right.
that's the interesting part for you.
Definitely. Like same way you were trying to discover things on your
Yeah,
own
that's right.
rather than being
Yeah.
given the information from a book.
A book or something like that. And so that's what I think the teacher should convey this impression. This is what I think needs to be done.
Self-discovery
Yeah, yeah.
rather than taking information
Not only
for granted.
self-discovery, that science is not over. Like the general impression one gets sometimes. From say one thing is that this is what Newton has done. This is what Einstein has done, and this is it. So go and learn it.
Right.
Okay, you will go and learn it.
Yeah.
But then so what? After that, what is there for you to do? Just go
What
and
have
learn
you
it
done?
is very boring.
You have to discover these on
yeah,
your own.
Yeah.
On your own, or no further things you have to discover.
Yeah.
So they
What
have given
have-
something to you.
Almost like what have you done now?
Yeah, now
They've
you have
done
to
so much,
build
but
on
what
it.
have you done?
Yeah.
Right.
That is the message. And but how to build on it and so on, you have to find your own path.
Right.
That nobody will tell you.
So one maybe a slight deviation from the
Yeah.
topic, but would you say that students who don't like mathematics as much still have a place in physics, or is it a necessity to know mathematics to a very excellent extent even just
Not
to do
necessarily.
research at this stage now?
Not necessarily.
Okay.
There are many things. There are so many. The field is so wide.
Right.
Some of the things need a lot of mathematics,
Mm-hmm.
but some things do not. So there are a lot of things in physics,
Right.
and many things are found without knowing also that you are doing mathematics.
Unknowing.
Many of the laser physicists, for example,
Okay.
the Sagnac interferometer, the triangle thing, many things they have found. There, some what are called. You have to cancel the laser frequency noise, what is called, and you combine the data streams in certain ways, and which cancels the noise. Okay, I mean, so you have to combine it in a such a way, certain way. Now that problem is basically finding equal length paths of equal length around the triangle, so that the noise cancels out because they are equal length. Now this problem is the same problem as doing LCM and HCM, finding an LCM, but LCM in a very more complicated ring.
Geometric ring
So it goes into algebraic geometry. So the problem is actually in algebraic geometry. But they did not know this was algebraic geometry, but they still found some solution. They did not find all, because algebraic geometry will tell you that there are infinite number of solutions. They found 2, 3, which were the simplest. But they found it without knowing any mathematics.
So, what are your thoughts on the university status of Fergusson College that we have recently acquired?
Being an alumni of the college, I feel this is a great opportunity for the college to really make excellent courses, design good courses, and have a good curriculum. Because now there's a lot of flexibility. There will be a lot of flexibility, and this flexibility should be used for the benefit of making the courses and all that, design the courses, basically interdisciplinary courses also, so that they can attract the best students. Now the technology and science are going so far ahead. Such courses are absolutely the need of the hour. And if you make such courses, you'll attract the best students.
Right. So we'll end here.
Yes.
And thank you for giving us this opportunity to interview you, and we're extremely glad to have a conversation with you.
Yeah, I'm quite happy to share my thoughts. So.